Hello everyone, welcome to Prevent the Solution given this nice Mathematical algebra problem, which is actually 2 to the power x plus x, this is equal to 70. So what is the value of x? Now solution here, so 2 to the power x plus x, this is equal to 70. So the first thing to do here, let's take x on the right hand side, we'll have 2 to the power x, this is equal to 70, subtract x. Now this is the same thing as 70, subtract x. This is equal to 2 to the power x. Now let's divide both signs by 2 to the power x. Okay? So that now we have 70, subtract x divided by 2 to the power x. This is equal to 1. Okay? Now from what we have here, if you have a, okay, if you have 1 over a, we can express basically this as a to the power negative 1. Okay? So applying this property, we'll have 70 subtract x multiplied by 2 to the power negative x. So this is equal to 1. So the next step here, you find that the exponent here, negative x, and if you check the coefficient, we have negative x, which is the same as the exponent here. So let's make the coefficient the same as the exponent by multiplying both signs by, let's multiply both signs by 2 to the power 70. Okay, so that now we'll have 2 to the power 70 multiplied by 2 to the power negative x. This is equal to 1 times 2 to the power 70. Now you can see clearly 2 to the power 70 times 2 to the power negative x. This is in the form of a to the power n multiplied by a to the power m, which we can express as a to the power m plus n. Applying this, we'll have 70 subtract x multiplied by 2 to the power 70 subtract x. This is equal to 2 to the power 70. Now you can see here the coefficient is the same as what we have in the exponent. So the next step here, now if you're given, let's introduce the exponent a, this to the power natural log of a. This is basically equal to a. Okay, so we can write 2 in form of the exponent as e to the power natural log of 2. This is basically equal to 2. Now applying this property, we'll have 70 subtract x multiplied by e to the power of natural log of 2. Alright, this raised to the power 70 subtract x. So this is equal to 2 to the power 70. Okay, so let's proceed. We have 70 subtract x multiplying by the exponent e to the power of natural log 2 multiplying by 70 minus x. This is equal to 2 to the power 70. So the next step here, if you have the Lambert W function of a multiplied by e to the power of a, this is basically equal to a. Alright, so if you have the Lambert W function of a multiplied by e to the power of a, this is the same thing as a. So for instance, if you have 2 multiplied by e to the power of 2, this is basically equal to 2. Alright, so from what we have here, let's introduce the natural log of 2 on both sides, so that we'll have natural log of 2, 70 subtract x, e to the power of 70 subtract x multiplied by natural log of 2. Then this is equal to 2 to the power 70 multiplied by the natural log of 2. By introducing the natural log 2, that is ln of 2 on both sides, we'll have ln of 2, 70 subtract x multiplied by e to the power of 70 minus x, ln of 2. So that now you can clearly see that this part, can call this one a, and this part actually is the same. All right, now applying the W function, applying this rampant W function, we'll have rampant W function of 70 subtract x ln of 2 multiplied by e to the power of 70 subtract x ln of 2. This is equal to 2 to the power of 70 ln of 2. So introduce Lambert W function on both sides. So now, applying this property, that is W function of A multiplied by e to the power of A is the same thing as A. So applying this property, we'll have 70 subtract x ln of 2, okay? This is equal to the W function of 2 to the power of 70 ln of 2. All right, and express 2 to the power 70 as basically as 2 to the power 6 multiplied by 2 to the power 64. Now let's substitute this. We'll have 70 subtract x ln of 2. This is equal to, now, W function of 2 to the power of 6 multiplied by ln of 2 multiplied by 2 to the power of 64. Okay? Now, if you recall, we have that if you have e to the power of ln of 2, this is the same thing as 2. All right? So substituting this, we'll have 70 subtract x ln of 2. This is basically equal to the W function of 2 to the power of 6. 2 to the power of 6, this is 64. So we'll have 64 ln of 2 multiplied by, now this is e to the power of ln of 2 multiplied by 64. Okay? So clearly, you can see this part and this part actually is the same. So applying the W function, that is the Lambert W function, we'll have that 70 subtract x ln of 2. This is equal to 64 ln of 2. Okay? So here, ln of 2 and ln of 2 simplifies, so that now we'll have 70 subtract x. This is equal to 64. So that means that negative x is equal to 64 subtract 70, which is actually equal to negative 6. So that means that x is equal to 6. X is equal to 6. Okay? So let's verify if this x, which is equal to 6, satisfies the equation. Let's verify. Now, if you recall, we end that 2 to the power x plus x, this should give us a value of 70. So this is 2 to the power x, which is equal to 6, plus 6, this should give us a value of 70. 2 to the power 6, this is equal to 64. So now you'll have 64 plus 6, this is equal to 70. So now you have 70 is equal to 70. So that means that the left-hand side is equal to the right-hand side. Okay? And that affirms that the value of x, which is basically equal to 6, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video. Bye bye.